Alright, you guys might notice that I'm hitting the most recent tests that we did, which is all of the quantitative data and the chi-square test, because they're just a little fresher in our minds, and I'm going to wait until I'm actually personally back on Tuesday and we will go back and do those z-tests for proportions together. I didn't want to start with those the day that I wasn't actually there. So this is chapter 25. This is the chi-square world. So let's take a look at this one just because we've not seen it for a few days. When two competing teams are equally matched means that they have equal chance of winning, so like 50-50 chance of winning. The probability that each team wins any game is a half. The NBA championship goes to the team that wins 4 games in a best-of-7 series. If the teams were equally matched, the probability that the final series ends with one of the teams sweeping 4 straight games would be 2 times 0.5 to the 4th power, which is 0.125. Further probability calculations indicate that 25% of these series should last 5 games, 31.5% should last 6 games. The other 31.5% should last the full 7 games. And then the 4 straight games was 12.5% up here. The table below shows the number of games it took to decide each of the last 57 NBA champs. Do you think the teams are usually equally matched? Give statistical evidence to support your conclusion. Okay, so this is about seeing if teams are equally matched. And equally matched is about, do these games actually fit the profile of what should happen? And when we're trying to get games to fit a profile, and we have one sample, this is actually this is the last 57 series. So it's a fairly large sample size. But there is just this one sample, and there's only one variable, and that's the lengths of the games, the lengths of the series. And even though lengths of series in games sounds quantitative, we're looking at them like they're categorical data, like we would graph them with a bar graph, which is a little bit weird. This is a harder thing than we would normally do, but since we're trying to see how well this structure fits these percentages up here, that looks like a goodness of fit test. So the first thing that we would do is look for an expected number of values. Okay, so we have a total, if we add all of these together, let's see how many games we have. 15 plus 22 is 37, 40, well, it's 57. That was stupid. I have a total of 57 series. 57 games, I guess I should say. Like I said, it's still like 6:30 in the morning this morning. And if I expect 12.5% of those 57 games to be 4-game wins, then I would need to take my 57 games and multiply by 0.125 to get that number of games that I'm expected, which turns out to be about 7.125. And then for the 5-game stretches, 57 times 5 games should happen 25% of the time, so 0.25. And that turns out to be about 14.25. And then in a 22-game or 6-game stretch out of the 57 games, we would have expected 0.3125 to last 6 games, and that is 17.8125. And then in a 7-game stretch, those are supposed to happen 31.25% of the times as well. So that's that same number, 17.8125. So the 4-game stretches, those are pretty close. The 5-game stretches, those look pretty close. The only one that looks to me quite a bit different is that 6-game stretch, 22 as opposed to almost 19. That's not a huge difference, so I'm anticipating that when I run this test, I'm probably not going to find a huge difference there. Okay, so chi-square tests we write in words, and our idea is, and I can look back here the way that they're worded, is do these 57 matches indicate that the distribution of the length of a series is consistent with that 50-50 chance. So the distribution of series length is consistent with a 50-50 chance for each team. And the alternative hypothesis is that it's not consistent. So I'm going to fudge here a little bit just because not consistent because of a time constraint that we have. Okay. Only 3 conditions to check with a chi-square test. One is randomness. We were told that this was the last 57 championships. So even though it's not randomized, we could assume that those are typical of all NBA championships. So we'll assume these 57 series are typical of all NBA championships, past, present, future championships. The data are in the form of counts. The data are counts. And last but not least, each of these expected values was 5. The smallest one was 7 point something. So all expected counts are at least 5. Now I noticed on the quizzes for Chapter 25, which I actually do have graded, and you should get back this morning. They're in a pile on my desk if you want to see those. That some of you are leaving out the word expected. It's not just any counts that matter. It's the expected counts that matter. So make sure that you're specific about that one. All right, so we're trying to see how well these series fit the probabilities that we should get if we truly had a 50-50 chance of winning for each team. So we're going to use a chi-square goodness of fit test. Mechanics are pretty short on the goodness of fit test. We do a degrees of freedom, and we really should show the work for that. So DF is 1 less than the number of categories. So 4, 5, 6, and 7 are 4 categories. So 4 minus 1 is 3. Then we compute our chi-square test statistic. That formula with 3 degrees of freedom, that formula is in our blue book. It says take the observed number of games. So in the 4-game category, there were 7 minus the expected 7.125 quantity squared over 7.125 plus 13 games minus the expected 14.25 squared over 14.25. There's only 4 of these, so I'm just going to go ahead and write them all out. Then 22 games minus the expected 17.8125 squared over 17.8125 plus 15 minus 17.8125 squared over 17.8125. And I want to finish those mechanics by running a test on my calculator. So menu and statistics and stat tests, and number 7 is chi-square goodness of fit. And the observed list, we need to do a control braces, which is your close parentheses key, and put in our observed numbers. So 7, comma 13, comma 22, comma 15. And then in the expected one, control close parentheses for braces, and 7.125, comma 0.25, comma 17.8125, comma 17.8125. degrees of freedom are 3, and go. Alright, so chi-square test statistic is about 2.47. Whoa, that's not, uh-oh, what did I do? Alright, I lost it, guys. Where is my, okay, I lost it, and I don't know why, but I have the answer written down, so we're going to pretend that I didn't lose it, and there's a chi-square test statistic on the calculator, hopefully on yours, not mine, of 1.54-ish, and that gives us a p-value, which is the probability of a chi-squared bigger than 1.54. We're always right-tailed because chi-squared is a right tail only, and that is 0.67-ish. That p-value is fairly large, 67%. There's nothing interesting about that, which I already anticipated because our expected values were so close to the observed number of games for the finals. So with a p-value of 0.67, I will fail to reject the null hypothesis at alpha equals, pick something, 0.05. There is no evidence that the lengths of series, again, I'm going to just repeat their words back to them, the lengths of series are not consistent with a 50-50 chance for each team to win. Alright, we don't have time to do a two-way test. The only difference in the two-way test is that we would need to put our two-way table, which is going to be a table with a variable across the top and a variable down the side. We would want to put our two-way table, not including any totals, into a matrix and store that matrix. And then when we run our chi-square two-way test, we would pull up our expected matrix using our variables key and take a look at that and write it down in our table. And the difference in the hypotheses would be for homogeneity is that the distribution of some variables is the same for all groups. And then for the independence is that one group is independent of the other group, or there's no association between this variable and that variable. Other than that, pretty much everything is the same. It would not hurt for you to kind of work through the mechanics of one of those one time. I just don't have time to do that on a video today. There are no confidence intervals for chi-square tests, so we don't need to deal with that. I have one last quick video on the linear regression t-test, which we just spent a short time on. We just want to take one look at those and then call it a day.